Okay, just a few more things about the antiderivative then. Let's go back to a velocity function, just making this up again. Maybe it's 5t squared. And to review with you, if I want the acceleration, I'm going to take the derivative of v with respect to t. And the derivative of v with respect to t, you're just going to take that 2 and multiply it by the coefficient 5. And so that's going to be 10 t to the first power. I have an equation that can, for any time, it will tell me what the acceleration will be. Okay, but if I want the function of x, how that changes with time, then I need to take the antiderivative. And I haven't told you about that notation. So that notation is going to look like this. I take the antiderivative of v with respect to time. Okay, so we can write this two ways. This is the antiderivative. Antiderivative doesn't have a hyphen. I think I hyphenated it last time. This is the antiderivative of v with respect to t. That's the lingo. Another way of saying this, though, is we can say that this is the indefinite integral of v with respect to t. And the way you evaluate this then is, in general, this is how you evaluate this equation. If you're trying to find the antiderivative of a function, if you're trying to find the antiderivative of, say, a function a times t to the n, where a is a constant and n is a constant, and you're trying to do that with respect to time, then what you do is you're going to add 1 to the exponent, and you're going to take your coefficient and divide it by n plus 1. And the reason that works is when you take this and multiply it by the coefficient, do you see how these cancel and you're left just with a? And then when you lop 1 off this, you'll just be left with n. So that's how you do that. And so if I want to take the antiderivative of 5t squared with respect to time, I am going to take just the antiderivative of this guy, and with respect to time. So the antiderivative of that is t cubed, and then I'll take that 5 and divide it by 3. That is the antiderivative of that. This function now will tell me, I'm sorry, we need a plus c. So this function will tell me where the car will be any time that I put in here. So at 1 second, it's going to be at 5/3, maybe meters, plus whatever it started at the beginning. So wherever it started, it will be 5/3 meters beyond that. A little bit more about notation. This symbol here is called the integral sign. That's called an integral. This here, that's called the integrand. And this here, that's called the differential. Notice that when I took the antiderivative of this, I only took the antiderivative of the integrand. I don't worry about the differential. The differential is reminding you that you're taking it with respect to time. So you're really only taking the antiderivative of the integrand. Okay, one other thing about this then. If you do have a v versus t graph, there you go. And let's say an object's moving like this. You remember that the area underneath this graph, say this area right here, it equaled something. And if you use your units, if this is meters per second and this is seconds, then when you do the 1/2 base times height to get the area of this triangle, you'll see that your units turn out to be 1/2 base times height. That's going to be in meters. So the area is a distance. It's really a change in position. And so the last thing I'm going to tell you for this part is that the antiderivative describes the area underneath a graph just as the derivative describes the slope of a graph. All right, see you next time.